Stoichiometry, or Stoic, is something you learned in Gen Chem, but if you didn't learn it or didn't remember it, then I'm going to review it right now. It's essentially just what stuff is reacting with what stuff in order to make other stuff. And it's the math you do to know how much is reacting and how much is producing. And you can convert using multiple different kinds of units depending on the concept. You use moles, which is just the unit of measurement that's easy for us to measure that we can see, because, chemistry is all about invisible stuff we can't see with the naked eye, like atoms and such. And so we use moles to help us measure in the lab. Molar mass is also going to be something we talk about soon. This is a concept map I have or will give you. It's the same one from Gen Chem. And essentially, it is all the concepts you can convert to using moles as our base unit. And so on one side, you have substance A, and one side you have substance B. So if you are converting from, let's say, carbon dioxide to water, you know that one side has to be carbon dioxide, one side has to be water. And then you have to figure out what unit you are in order to measure, and you can only go through the arrows. You can't skip any steps. So if I had particles of something and I wanted mass of a different substance, I would need to go through this arrow, then go through this arrow, and then go through this one. This one is not fully completed yet. We will complete it in class, or I will give you time later. If I don't give you time, then I'm going to show you what's filled up right now. You can see in the filled up version, we have it mirrored. So if it's on the left side, it is on the right side. And so you can see here, you have this many particles in a mole's worth of a substance, and then you have this many particles. This is Avogadro's number. I just shortened it to Avo. And so that is the concept to go from particles to moles. In terms of particles, we have different kinds. So the ones we usually deal with are the ones down here. So we deal with atoms, ions, molecules, and formula units. And we use certain ones depending on what we're talking about. Are we talking about ionic stuff? Are we talking about covalent stuff? What are we talking about? And so we use certain ones, again, depending on what we're doing. You can see if we want to go to mass, which is the unit grams, it's the concept of molar mass. You have to use your periodic table to find that value to go to moles. If we have a solution, then we can get the volume in liters, which is molarity. And then if we have a gas, specifically at STP, we'll talk about that way more in the gas unit, and then we can use that relationship here. We have the mole ratio in the middle. So from the previous section, we talked about balanced chemical equations. And so the coefficients that we wrote on the front, those are the numbers that we'd use to go from 1 mole of one substance to another mole of another substance. So we have the different moles and its relationship with stuff. And so we're going to go ahead and talk about that. And so, obviously, with chemistry, again, things are invisible. And so we can't directly count particles in order to figure out how much of a substance we have. And so we have the defined moles. And so we can, measure the mass of something that is going to react to something else, and then we could figure out the moles from there. And so that's why we have that as a unit. And so Avogadro's number, as I mentioned, it is the number of particles or constituent particles in whatever mole's worth of stuff. And so these particles, there's different kinds, as I mentioned earlier, so make sure you know those different kinds that are on the concept map. F dot U dot, that's formula units. I know it looks like that, but it's formula units, okay? So just keep that in mind. So the particles unit here can change to any of the ones that we mentioned earlier. Okay, so mass units. Now, the concept map, we were talking about the grams, and that is based off a mole's worth of a substance. versus an atom. Those are two different things, okay? So you want to make sure you know individual atoms and molecules, we measure that in AMU, which is atomic mass units. A mole's worth of a substance we will measure in grams. Make sure you know those mass units between these two different things. Again, individual atoms and molecules are AMU, atomic mass units. A mole's worth of a substance is measured in grams. So we have other relationships to the mole. And so some of the relationships we talked about on the concept map. So we have Avogadro's number, as I mentioned previously. It's the number of particles, such as molecules, ions, and so on. We have molar mass. So it is the number of grams, that's what the blank space is there, divided by 1 mole. You can flip-flop it depending on what units need to cancel for Stoich, which I'll show, in a few more slides. And so the molar mass you get from the periodic table. So if you know the formula for something, so for example, water is H2O, I would look up the H, what's the mass of H? I would multiply that by 2 because it's H2, and then for oxygen there's 1, and so I would add those together to get the molar mass of water. So the other relationships that were mentioned in the concept map, as I said here, it's going to be in the later units. So the molarity for solutions is the number of molar. That's what the big N stands for. And so that corresponds to whatever number of moles per 1 liter. Again, as it says here, we'll focus on that in a future unit. Same goes for the gases at STP. That is a defined value, and you do not need to memorize the defined value because it will be given to you on your equation constant sheet from College Board. Here is another version of a concept map that's talking about the conversions between moles. It just has a little bit less, but some people prefer straight lines rather than curves like the one I made. So just, whatever you want to use. If you want to print this out, you can go on the slides or go on the classroom website, and then it will be on there as well. Okay. If we need to calculate molar mass with polyatomic ions, you want to be very, very careful. And so you need to multiply stuff out. That is the thing that confuses students. So here are 2 ions. So let's say we're getting the molar mass of aluminum sulfate. So aluminum is going to be +3 and sulfate's -2. And so in ionic compounds, we need to balance those charges. And so in order to balance those charges, I'm going to need 2 aluminums and 3 sulfates. So when I write that formula for that ionic compound, I get this. And so on my periodic table, I would need to look up each of these symbols and the molar mass of that particular elemental symbol. So I'm going to show the work fully, but you do not have to show your work like this. If this was asked on an FRQ, you don't need to list every single element. You would just need to show that you are multiplying stuff together and adding stuff together, but I'm showing everything in case you don't remember molar mass. So aluminum, there are 2 of them here, and so since it's 2 of them, I take the mass given on the PT, 2 times that mass, and then I get that value. And so now I'm looking at the polyatomic. Here's where it gets tricky. Sulfur's in parentheses, so you want to make sure that you multiply the subscript of sulfur and what's on the outside to know how many sulfur there are. And so I'm going to show that right here. There is 1 sulfur in the parentheses, and then on the outside of the parentheses there is a 3. That is why it's 1 times 3. And then I looked up the molar mass of sulfur, and then I get my value here. I do the same thing for oxygen. So in the inside, oxygen is 4, and the outside it's 3. So therefore 4 times 3 times 16, because that's on the PT, and then I get 192. So the full molar mass of this is going to be adding up those 3 things. So you take the aluminums, the sulfurs, and the oxygen, add all those up, and you get your molar mass. Again, the units for molar mass is grams per mole. It is always 1 mole of something to whatever is on the PT for that substance. So you don't need to show your work for molar mass. The assumption is you know how to do it, as you can see right here, unless it's an FRQ and it specifically asks what is the molar mass of something. So if it's like part B, what is the molar mass of blah, 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 then you have to show your work in some capacity so that way, the grader knows that you know what molar mass is and how to calculate it. There will be, honestly, questions where they give you the molar mass already because they want you to do the stoic math rather than the calculations of molar mass. So you want to keep that in mind as well. So make sure you know what molar mass is and you can calculate it. Now, the other biggest thing about molar mass is a definition. It is a defined value. It is not part of sig figs. Let me repeat myself one more time. Molar mass is a defined value. It is not part of sig figs, so therefore it has an infinite amount of sig figs. Don't forget that, especially when you have to round answers for sig figs. You do not take molar mass into account. Okay, so now I'm going to go over an example that's slightly trickier. So this is, an Avogadro number, and it's using Stoich, which is why I have the concept map right behind me. And so I'm trying to get the chloride ions involved in this question. So I notice that it is giving me the substance magnesium chloride, okay? And so I'm going to go ahead and see that magnesium is +2, chloride's -1. I knew this because I looked at my periodic table and followed the pattern of the charges for those two ions. And so because those are the charges, I have to make sure it's balanced. And so the balancing of those charges is MgCl2. Cool. Okay, so now I have the grams of magnesium chloride, so that means I am currently here, grams of magnesium chloride. I need to find the molar mass in order to calculate from mass to moles. And so I use my periodic table for that. So magnesium is 24.30, and then I have 2 chlorines, or chlorides rather, so 2 of those, and each of them are 35.45. And so when I do that math, my molar mass is going to be 95.2 grams per mole. Cool. Okay, so now I'm going to use that as my conversion factor. I want to make sure my units cancel out. So first I'm going to start off with what was given in the problem. I have 549 grams of this guy. So 549 grams of MgCl2, and then my molar mass here is 95.2 grams of that substance. So I'm going to go ahead and put that on the bottom because I want to make sure my units cancel. If you notice, I'm putting the actual formula in the writing of my work, mainly so I make sure I keep track of what is canceling with what. It is very handy doing Stoich where you're writing this, especially when you're converting from one substance to the other. And so this conversion factor here is that. Remember that anything slashed is 1 of whatever unit is here, so that is 1 mole of that substance. So 1 mole of MgCl2. So again, this conversion factor here was just based off this. My grams of that substance cancel out, and so I'm going to go ahead and do that math right here. So 549 times 1 divided by 95.2, that is going to be 5.79 moles of MgCl2. And so you can see here that my sig figs is 3 because I have 3 here, and this is a definition, so it does not count, and so I have 3 at the end because of the multiplying rule. Okay, so now I have moles. I'm trying to go from moles to particles because I'm asking for ions. You want to be mindful about that because we have this many magnesium chlorides, but the chloride ions are not the same. You want to be very careful. So personally, instead of going through number of particles and then thinking about it, I'm actually going to go across. I'm going to say that substance A is magnesium chloride and substance B is just chloride ions, just to emphasize kind of mole ratio, except not with a balanced equation. And so for every 1 mole of MgCl2, because that is substance A, how many moles of chloride ions do I have? I look at the formula. For every 1 mole of this, I have 2 moles of chloride ions. So I'm going to go ahead and put, 2 moles of chloride ions. And so I'm going to take that value, multiply it by 2, and then I will get my answer in moles of chloride. When I do that math on a calculator, I end up getting 11.58 moles of chloride ions. So now I'm at moles of chloride ions because I traveled from this arrow to this arrow. And so what I'm going to do is now go from moles of chloride to particles of chloride, which in this case are ions. So I'm going to be using Avogadro's number, which is on our constant equation sheet. So you actually don't need to memorize the number. You just want to make sure you know where it is. And so for every 1 mole of Cl minus, there is 6.022 times 10 to the 23 ions of chloride ions. I know I said that twice. And so when you do that math, you end up getting 6.95 times 10 to the 24 chloride ions. Cool. And so that is pretty much how you would calculate those ions. Now, you want to be careful about sig figs. I told y'all when we talked about sig figs, you want to do sig figs at the end. You can obviously keep more units, but I decided not to when showing my work here just to keep it brief. But if I did this first step here, I would actually save this number on a calculator, whatever it is with a million bajillion digits. I just remember it would be 3 sig figs, and then counting, like mole ratio, is not part of sig fig, so that wouldn't count, so it'd still be 3. And then Avogadro's number is a definition, so that also would not count for sig figs, so your answer at the end should be 3 sig figs. So do keep that in mind while you are calculating. All right, so here is your turn. You want to make sure to use your periodic table, and if you need to, use the concept map. You eventually shouldn't be using the concept map. It should be intuitive on how to cancel out units and stuff, but for now, since this is the beginning, go ahead and use it. So go ahead and look at this problem. We have 3 different samples, and we are trying to organize these samples based off this. So we need to find the number of particles for A, B, and C. We need to find the mass of A, B, and C. We need to find the moles of A, B, and C. So you need to do a bunch of conversions as practice. So again, for all 3 of these problems, you got to convert to whatever's asked. So particles for number 1, all 3 need to be in particles. Again, increasing mass, you need to see the grams, and you rank them in order. And that's pretty much it. So we learned 2 relationships as a reminder: molar mass, which is the periodic table grams per mole, and Avogadro's number, which you can see right here, is particle unit divided by mole. So you want to just make sure that you can use those conversions. So go ahead and pause the video and try doing it yourself. All right, I'm going to talk about each of the answers for these. So for question 1, we need to convert everything to particles. The sample C is already in molecules, which are particles, so you don't need to do any math for C for the first question. You need to convert A and B, though. So for A, we are at moles, and so we want to go to atoms because it is just 1 element, so we're just talking about an atom of that. And so I use Avogadro's number for that. And so 1 times Avo's number divided by 1, that's just going to be Avo's number, approximately. I rounded to 2 sig figs because it's 2 here. And then for sample B, we have mass. So if you look over the molar mass, because that's what you have to go through, and then you need to go from molar mass two particles. In this case, we're going to use molecules because it's a covalent compound. And so I have highlighted in green here, we have the molar mass of CO. So I make sure that grams cancel out and have moles of CO at the end. And then I use Avogadro's number with molecules divided by a mole's worth of that. So I do 18 divided by 28.01, multiplying by Avo's number. And as you can see right here, we have 3.9 times 10 to the 23. We have 2 sig figs because in the problem it was given as 2 sig figs because it was 18 grams. So the answer comparison, again, we're increasing number of particles. So C has the least amount, and then B has the next, and then A has the most. And so that is the order of operations for this. Okay, so now we have question 2. So we need to go to mass for everybody. We notice that sample B is in grams already, so I don't need to do any math for that. And so for sample A, I have a mole's worth of carbon specifically. So we're starting off with that. I find the molar mass of carbon on our PT. I make sure moles cancel out, and then I just do the math, which is just, multiplying and dividing by 1. So it's just 12.0. I noticed that I didn't do sig figs because you want to be careful about that. This is 2 sig figs here, so therefore this should actually be 12 grams of carbon. So be careful. Okay, so now we're doing sample C. So C right here is 3.0 times 10 to the 23 molecules, and we're trying to go to mass. So that is a 2-step problem because you have to follow the arrows on where'd you start, where'd you go. And so since we're starting with the molecules of water, I need to use Avogadro's numbers first because as you can see here, you're going from particles to moles using Avogadro's number. Then we go from moles to grams using molar mass. So we have the value that was given in the problem. I make sure molecules cancel out, so Avo's number is on the bottom and moles worth is on the top. And then I'm left with moles of water as my unit. Then I use molar mass. I looked up what H and O was, multiplied the H by 2, and then added them together. And then I put a mole of water on the bottom because I wanted to make sure those canceled out. And so I'm left with grams of H2O at the end, and I get 8.8. So there we go. And so when I'm comparing my answers, the order should be CAB. So that is how I would answer question 2. So for question 3, we need to convert everything to moles. Sample A is in moles already, so I don't need to do anything for that. In sample B, I have grams, and so in order to go from grams to mole, I use molar mass. So I look up CO, I add them together, I get 28.01. And so I want to make sure grams cancel out, so that's why this is on the bottom. And then I do 18 times 1 divided by that, and that's going to be 0.64 moles of CO. For sample C, I have particles, so I need to make sure I go from molecules, because that's a particle, into moles, and so I use Avogadro's number here, and then you can see I get 0.50 moles of water. And so when I'm comparing the answers to these, C is going to be the least because it's 0.5, and then B is 0.6, and then A is 1, and so that is why that is the order. Okay, so now we need to do Stoich calculations. So again, it's just calculating the amounts of reactants and products depending on what the question is asking. You're just getting the quantity of those things. And so you need a balanced equation most likely. If I am going from one substance to another, you definitely need a balanced equation. If you're only sticking to one substance, then you probably don't need it. We have to unit cancel, so as the previous examples in your turn are, you want to make sure that you can cancel out units properly. Like I showed in my work, you want to keep the formula in the unit canceling because when you convert from reactants to products or from one substance to another, it gets very confusing when going through the mole ratio, so I recommend putting it in. I see some students who don't and they're fine, but that depends on the student, so I recommend keeping it in there. And so if you get confused on a word problem, Honestly, doing the guess method helps a little bit. Just doing the G and U part helps, just so you know what is given in the problem and what are we actually solving for. And so again, as a reminder, you can go from mass or moles or volume or the different particles with Avogadro's number. All right, so we're going to go ahead and go over an example. And so here is a balanced equation. Now, I do recommend always checking if an equation is balanced. Most of the time it is on College Board's thing, but sometimes they throw a curveball. So it's always just to like check real quick. 3 C's, 3 C's, 8 H's, and so on. But it's balanced, I'm already just going to tell you. And so here's an example using this balanced equation. If I have 120 grams of CO2 that's made, how many particles of tricarbon octahydride there are. So you want to make sure you know your givens, you know your unknowns. And so I'm going to go ahead and just write them down real quick. So our given, G, is going to be 120 grams of CO2. My unknown is particles of tricarbon octahydride. So looking at this equation, I can find tricarbon, that's this one, and octa, so they has to be C3H8. So I'm going to say C3H8, and that is our unknown. So I'm going to go ahead and put a question mark there. So what I personally like to do is think, what units do I need to go through, and how do I get there? So I'm going to talk about it via the concept map. So here is a mini version of it. So I'm going to go ahead and just circle where are we starting and where are we ending. So we're starting at 120 grams of CO2. So substance A is going to be CO2. My substance B is going to be C3H8. And so I'm going to go to particles of C3H8. So I'm going here. So following the concept map, I'm going here in this arrow, then I'm going to this arrow, and then I'm going to go up here to this arrow. So this is going to be a 3-step problem. So just to emphasize what I just circled and arrowed here, I'm going from mass of CO2 to moles of CO2. Then from moles of CO2, I'm going to moles of C3H8, and then I'm going to particles of C3H8. So that's the steps I went through for the whole thing. And so I'm going to go ahead and do that. So my mass of CO2 was 120 grams of CO2. And so that is going to be the first box. I'm again going to moles of CO2. So I have to use molar mass of CO2. I preemptively could tell you it's going to be 44.01 grams. Remember, you have to add all the masses up together and multiply by any unit that has more than one. So in this case, oxygen has 2. And so the 44.01 grams is going to go on the bottom because I want to make sure units cancel. So grams of CO2 to 1 mole of CO2. And so my units of grams CO2 are canceled out. I just did this step and I went to moles of CO2. And so now I have to go from moles to moles using the mole ratio from the balanced equation. So looking up here, I'm trying to go from CO2 to C3H8. CO2 has a 3 in the front. I want to make sure moles of CO2 cancel out. So I'm going to put that on the bottom, 3 moles of CO2, because again, that's from the balanced equation. I'm trying to go to C3H8. I have an invisible 1 mole here, so that's going to be 1 mole of C3H8. And so my moles of CO2 cancel out. I am now past this step. So I did this one, now I'm at moles of C3H8. And so I need to go to particles. And so in order to go to particles, I need to use Avogadro's number. So Avogadro's number is that big number with 1 mole of that substance. So I want to make sure 1 mole of C3H8 is on the bottom, and then Avogadro's number is on the top of C3H8. I wrote atoms, I meant to write particles. Yeah, just fix it. Particles. Cool. And so there you go. And so I would put this all in my calculator. I would do 120 divided by 44.01 divided by 3 and multiply it by Avogadro's number. And so when I do that, I end up getting 5.5 times 10 to the 23 particles of C3H8. So you want to be mindful about your sig figs. Don't forget. So I'm going to go through all the sig figs here. So here we have 120. There is no period at the end, so that has 2 sig figs. The molar mass is a definition, so none of these count. Mole ratio doesn't count because that's just counting from the balanced equation. Avogadro's number doesn't count because that is just a defined value. So none of these count except the given in this case, and it's all being multiplied, so you want to make sure it's 2 sig figs at the end, which is what I ended up doing in this example. Okay, next example. So we have 5 grams of oxygen. That's going to be our given. I'm just going to label it right below. So there. That's our given. And so we have an infinite amount. That doesn't matter. We just have a lot of it. Who cares? How much water in grams can I produce? So I have grams of oxygen. That's going to be substance A. So I'm just writing that here for reference. And then I am going to water, which is an entirely new substance. And so you can see here I have labeled substance B, water. So I have 5 grams of oxygen. That means I'm starting over here. I'm going to grams of water. So that means I am going here. So I'm going to go through one step here. I'm going to go through a second step over here. And I'm going through a third step over here. So those are the 3 steps that I'm going to be going through. And so just to recap, we are going from the mass of oxygen to the moles of oxygen, moles of oxygen to moles of water, and moles of water to mass of water, aka what I just said on the concept map. And so I'm going to go ahead and show my steps. So I have my 5 grams of oxygen, and then I find the molar mass of oxygen, which is 32 grams. I want to make sure the 32 grams cancels out, so that's going to be on the bottom. And in molar mass, we always have 1 mole of that substance. I'm going to go ahead and now use the mole ratio. So oxygen has 5 moles worth, so that's going to go on the bottom to make sure units cancel. And so I am going to water. Water right here is 4, so that's going to go on top. And so my units are canceling. I'm just not showing it. The grams here cancel, the moles here cancel, and so on. And then I need the molar mass of water. If I do the calculation, it's 18.016. I want to make sure that's on the top because you want grams on top and you want the 1 mole of water because, again, molar mass is defined as 1 mole's worth of that substance. And then I do that calculation. 5 divided by 32 times 4 divided by 5 times 18. And so I get 2.25 grams of water. I want to check my sig figs. So 3 sig figs here. This is a definition. This is counting. This is a definition. So therefore it needs to be 3 sig figs because of the multiplying rule. So to recap what we talked about, we have volume of a gas at STP, which again we'll focus on more in the gas unit. We have molar mass, which is grams on the PT divided by 1 mole, and then you can move it around depending on what units you need to cancel. Particles is Avogadro's number divided by a mole's worth. Now, I am defining Avogadro's number a little bit here, at least some of the units that could be particles. So for example, atoms, it depends. Atoms is used very broadly, so it's contextual, which we'll go over in future sections. And so there you go. For molecules, molecules are only covalent. And as a reminder, covalent is nonmetals only. And then formula units are for ionic compounds, because we will talk about that when we talk more about ionic compounds. So this is the summary. I know that it can be confusing. I know Stoic is terrifying for some students. But honestly, if you remember a few things and you super duper cancel out units, it's not so bad. And Stoic is super duper the bread and butter of chemistry, especially in college. So make sure that if you're not understanding it, get help. I'm also going to be talking about a little bit more of Stoic, just a smidge more. So hang tight. The last thing about Stoic is doing calculations with a limiting reactant. So just like as I said in the first bullet point, we went over examples where it was only one substance. If you have two substances involved, then you want to make sure you do all the math that we just did twice for both substances. And so if you're like, ugh, that's annoying, you're right. It's very annoying, but sometimes you just got to do it. So I'm going to go ahead and do the guess method real quick. So the givens in this problem, we have 20.0 grams of sodium phosphate. So sodium phosphate, Na is +1, phosphate's -3, so I'm going to need 3 NAs, PO4. And then the other given in this problem is going to be 35.0 grams of calcium chloride. Calcium's +2, chloride's -1, so that's going to be CaCl2. Cool. And then our unknown is how many grams of sodium chloride. So we're trying to find grams of NaCl. It's ±1, so that is our unknown. Cool. So as I said in the second bullet point, whichever makes the least amount of product is the limiting reactant. And so you have to do this math twice. Now, the first thing you want to do is write down the balanced equation. So we have the Na3PO4, and then we have the CaCl2. Those are the two reactants because it says reacts with. And then you're producing, bam, we have calcium phosphate, so that's going to be +2 -3, so that's Ca3 parentheses PO4 parentheses 2, and then we have NaCl. I will balance this in my head. So we have phosphate 2 here. I have 1 phosphate here, so I could put a 2 there. I have 6 NAs, so I could put a 6 here. I have 6 CLs, that's written badly, and then Cl2 here, so I could put a 3 there, and we are balanced. Perfect. And so I noticed I have grams here, and I'm trying to go to grams, so I need the molar masses of everybody. So I'm just going to write it on the bottom here. If you do the calculation for Na3PO4, you're going to get 163.94. Again, this is molar mass, so G per mole of the first one. Calcium chloride is going to be 110.98 grams per mole, and then the NaCl is going to be 58.44 grams of NaCl. So, like I said, you do the math twice. I'm going to show the work for one of them, and then the math is exactly the same, but you change the molar mass and stuff for the other reactant. So, for example, I could do the 35.0 grams of CaCl2. So this is the work for CaCl2. So I'm going to start off with my 35.0 grams of CaCl2. If I look at my concept map real quick, I have my mass of CaCl2 here. I'm going to go to moles, moles to moles, moles to mass. So I'm going through 1 step, 2 steps, 3 steps in order to get there. So I'm going to go ahead and do that. I take the molar mass of CaCl2, which is 110.98 grams of CaCl2 to 1 mole of CaCl2. And then I need to use the mole ratio. So I need 6 moles of NaCl, and then I have 3 moles of CaCl2. And then I use the molar mass of NaCl, so I have 1 mole's worth. Oh, I forgot the moles here. I have 1 mole's worth of NaCl, and then 58.44 grams of NaCl. Cool. And then if I did the math for this, I will get 36.9 grams of NaCl. NaCl. And then I would do the exact same math, except I would do it for Na3PO4. So I would have 20 grams of Na3PO4 here. I'd have the molar mass of that, which is 163.94. I would use the mole ratio, except instead of 3 moles of CaCl2, I would use the 2 moles of Na3PO4 here on the bottom, and then this part would remain the same. If I do the math for Na3PO4, the math for that ends up being 21.4 grams of NaCl. And so it's whichever makes the least amount. So basically I would have done the math for this, and this would be our answer, and you would want to make sure you emphasize that if this was an FRQ question. So here is your turn. You have your references, so I would pause the video on these questions you can see here on the screen, and then try it yourself, because the best way to get good at Stoic is honestly practice. So go ahead and pause and try these out. I have my question here, and then I have my balanced equation. I listed my givens and unknowns just to make sure I know what I have versus what I'm solving for. I have labeled, as you can see highlighted here, what every single part is. So you can see here I have my givens. In the middle here, in my first step, I used molar mass. I used the mole ratio from the balanced equations to get these numbers, and I get molar mass of CO2. I have these two values here I have highlighted. But remember, since it's two different substances, you have the least amount made. So the least amount is 2.98 grams of CO2. So that would be my answer for the first one. For the second one, here it is. And so we have the amount of atoms of Fe, the grams of chlorine. I wrote down the balanced equation here. Make sure you know diatomics. If it's not diatomic list, it is by itself. There's only one of them. You have the balanced equation here. I listed my givens and unknowns. I can see here I have two different starting points, and so they have different conversions. So since I have atoms, I use Avogadro's number, and then I use the mole ratio to get moles of FeCl3. Then I do the calculations for the chlorine. So the chlorine is grams. I use the molar mass of chlorine here, and then I use the mole ratio here to get this answer. I compared the two answers, I click the least amount, and then there we go. And that is the end of Stoic Review, with its various units like moles and particles and whatnot. As I said, I will go over the other relationships in future units, and so we will also practice this skill a lot throughout the year. We're obviously going to practice in the beginning of the year too, but we're going to super duper practice Stoic all the time. So if you're like, oh my gosh, I'm so confused, don't worry, I got you. We will practice. All right, I'll see you in the next one. Bye!